Hello students, welcome to the course Design Pattern, course code SAD304. In this session, we will learn Composite Design Pattern. In this session, we will start with an introduction of Composite Design Pattern, then we will cover intent, examples from application level as well as the real world level, the motivation behind of using Composite, participant classes. Participants are those classes which are the core and the foundation classes for implementation of Composite, and then the information flowing among the participant classes. And to understand the composite pattern, we will see a scenario, and then we will design the UML for implementation of that scenario, and then we will model the UML into the code. At the end of this session, you will be able to represent the part-whole hierarchies of objects in your application. It means when you have information in some hierarchy or hierarchical form, you can represent it or store it inside your application using composite pattern. It will also enable you to have a tree structure and ask each node in the tree structure to perform certain tasks or functionality. It will also enable you to treat the individuals and as well as composite object uniformly. Composite design pattern describe that a group of objects is to be treated in the same way as single instance of an object. It means when you have to store some objects in your application, then some of the objects are single primitive and some of the objects can be composite. What is meant by composite here, that the object is composed of different other objects of their own kind. For example, let's see, in data structure, you have different data structure to store the information in the form of hierarchy. Let's take the example of a tree. In a tree, you store textual data, you can store numeric data, but information that we store in tree is in some kind of hierarchy. So but the tree contains all information of same kind in all nodes. So similarly, when we have a customized object with the customized information but in form of some hierarchy or some level, then we can use the composite design pattern to store that information. So this type of design pattern comes under the structure category, as you are going to create a hierarchical structure for representation of your composite object. Composite design pattern compose objects into tree structure to represent part-whole hierarchies. Part-whole hierarchy means you have information in some level, in some hierarchical form. It means there is some parent node and there is some child nodes as well as the other children. Inside the child nodes, there can be leaf node or there can be composite node. So composite lets the client to treat the individual and composite object uniformly. Uniformly mean in the same way. As you know that some applications needs to manipulate a hierarchical collection of primitive and composite object. So processing of a primitive object is handled in one way, and the processing of composite object is handled in different way. So checking type of each object, either it's single or primitive or composite, before invoking any operation is not recommended approach or is not efficient approach. So there should be a uniform way, a same way to treat both kind of objects equally. So the key concept behind of using composite design pattern is to manipulate a single object as well as the composite object uniformly. So this pattern creates a class that contains the group of its own object. To understand the representation of information in composite object, just consider it as you use a tree kind of data structure for storage of numeric or either string data. As in this diagram, you can see that information is represented in a tree structure. The tree has different levels. The first node is parent node because it have for the children, and to represent the children, it have two branches, and both nodes are composite. They are composite because they further contain their child or their information in their hierarchy. And the leaf node means the node is having further no children, or doesn't have any inside hierarchy or further level. So to decide that which what is the level and what is the height of the tree, it will be dependent upon the requirements or the information or the scenario which is given to you. So just understand the composite tree as the normal tree data structure that you practiced in your early programming. There are many examples and the practical applications where you can use the composite design pattern to store hierarchical information or the information which has some levels. For examples, the menus that contains further submenus and sub items, and for each of item there could be a child menu. So you can use the composite as the information is in the hierarchical form. Similarly, row column GUI layout managers, they also contain some widgets, so each of widget could be a row column GUI layout manager. Similarly, containers in different languages like Java containers that can contain the elements, and each of which could be also a container and contains the nested other controls. And also the directories that contains the files, subfolders, and similarly, a file could be a directory because it may contain other folders and subfolders. So classic Windows folders and files are also examples of information in a hierarchical form. Windows folders are files are composite. Files can be leaf because they may not contain further any folder, subfolder, or files. But you can see that a double click or either of them opens the file folder, same operation is being used. So by using or implementing the composite design pattern, you have to provide the uniform methods to treat the composite as well as the leaf or the basic object uniformly. And inside the example of this classic window folders and file system, double click is a unified operation which is used to open all kind of folders, subfolders, and file. To represent the examples of Windows folders and file system as a composite or tree structure, you can see this diagram that at parent node or root node there is a directory. Directory may have other subdirectories or files, so it have three branches, and the two branches are further having children of ordinary files, and the third child is leaf because it doesn't have any further branch or any information to store. Similarly, the directories, subdirectories may have other subdirectories and files. So you can represent the level of folders and files into a tree structure. So similarly, composite pattern will also contain and represent the information which is in level as a tree structure. To understand the tree level information, you can take the example of hierarchy of an organization. You can see that a company organization may have multiple employees. They can have thousands of employees, but the designation and the level of each employee is not same. Some employees are of superior level. They can be supervisor, they can be manager, and inside of managers and supervisor, they are low level workers or low level staff which is working under their supervision. So you can represent company structure or the organization structure to display the level of employees. You can also use a tree level structure, and you can see in this diagram at top level there is a CEO, and CEO has further managers for each department, and inside the manager hierarchy there is team lead, and the software engineer are under the team lead. So this is the representation of a software company, and you can see that how the employees are in different levels. Now let's see some motivations behind of using the composite design pattern in your application. When you are dealing with the tree structure data, means the information which is in level, the programmers have to often discriminate between a leaf node and a branch. Why they have to discriminate? Because they have to put some check and balance. They have to put some if and else if conditions, that if the object is of composite type, then the following or some operation should be invoked. And if the object is leaf, primitive, or single, means it is not composed of other objects. So you can invoke, or a programmer can invoke a different kind of operation. So there is discrimination between leaf node and branch, and this makes the code more complex and more error prone, because you are keeping check and balance for every node, at every node, and at every level. So the solution is very simple, that you can use an interface that allows treating the complex and as well as primitive object uniformly. So in object-oriented programming, a composite is an object-oriented as composition of one or more similar kind of objects, all exhibiting similar functionality. Why we have to exhibit similar kind of functionality? Because we know that we have to store the similar kind of objects inside the composite object, because and as in data structure you used to store the similar data type of information inside a tree. Means if a tree is numeric, then it will contain all the numbers, and if it's string or character, it will contain the same data types. But the node can be composite or leaf, because it may contain sub hierarchy, or it may not contain any further information to display. This is the general structure of composite pattern to represent the part of hierarchy. In this diagram, you can see there is a base abstract component class that specify the generic behavior that need to be exercised uniformly across all primitive and composite objects. The subclass, which is primitive or composite classes, they contain and they inherit the default behavior from the base class. For example, the operation is a common method or the uniform method. It can be of any name, which is defined in all nodes, regardless they are composite or primitive node. Child management methods such as adding a node, removing node, and traversing mechanism, they are mostly defined in the composite class, because the composite nodes have to add or remove their child, whereas the leaf node doesn't have the methods for the child management class. So you can see in this diagram that the leaf class and the composite class both are inheriting their base class, which is component class. And you can see that inside the composite node subnode, there is a iterative way to call the operations of all the child nodes recursively. So we can treat the composite as well as leaf node inside this composite structure uniformly using the composite pattern. The important participant classes, which are the foundation classes to implement the composite pattern inside your applications, are here as listed. The first is the component class or the base class, as you have shown in as you have seen in the earlier slide. The component or the base class declares the interface for objects in composition. It implements the default behavior for the interface common to all subclasses, the primitive or composite. It declares an interface for accessing and managing its child components. As you have seen that it contains the adding child and the deleting child method inside it, whereas the leaf node or the leaf class represent the leaf objects in composition. Leaf have no children, so it doesn't need to have the child management method for adding or deletion. It defines the behavior, generic behavior for primitive objects. Primitive objects mean single objects, which are not composite in nature. Why they are not composite in nature? Because they don't have any further hierarchy or level of information inside them. Similarly, the other important component is the composite class, which will inherit from the base or the abstract class. It will define the behavior for all the components which are non-primitive, which are composite, and they are having the children. So they store the child component, which is of their own kind, and implements the child-related operations in the component interface. And to use the all classes, there is the client class. The client class manipulates composite as well as primitive object uniformly using this composition and this generic component interface. The flow of the work among the participant classes is described here. The client will use the component class interface to interact with the objects in the composition structure. And if the recipient is leaf node, means they don't have any children, then the request will be handled directly, or the operation will be remotely called. If the recipient or the node is composite, means it contains further level of information, then it is forwarding the request to its child or the number of children for performing the additional operations. We are demonstrating the use of composite design pattern at code level with an example in which we will show the data of employee in some hierarchy, because we know that the organization contain or have employees in some hierarchy based on their seniority and their experience and their area or the domain. We know that there is a CEO which is at the top level, and then other levels will be according to the levels and the designation of the employee. So we will use this employee structure information to store inside the composite structure. This is the UML representation of showing or displaying the employee's information in a hierarchy using the composite design pattern. We know that the object which we are going to store is employee, but the employee have different types or different kinds based on their designation, based on their job nature, but all different kind of employees which are in different levels are having the same parent kind, which is employee. So the base class is listed as employee. It will contain all the default behavior and the default functionality of employee object. It will contain the general information of all kind of employees, because you know that employee will have its ID, its name, its salary, and there are some child methods to add child management methods to add and remove the employee. And similarly we can see the levels of all employees using the print method. So print method will be the basic operation that we will treat uniformly in the primitive employees as well as the composite employees. Primitive employees mean single employee which doesn't have which doesn't have other employees inside of it hierarchy, and the composite employees are at that level of employee which have further children and further sub branches or hierarchy of employees under their supervision. So the employee is a base class, and the other kind of employees are bank manager, cashier, and accountant. So we are taking the example of a bank company or bank organization. The bank manager may have different kind of employees inside of its hierarchy, because it manages other employees inside its organization. So we have inherited the basic functionality of employee, such as ID, name, salary, and the getter setter method of their this default attributes. And as well as we have also listed the adding and removing of employee, because it may contain its own hierarchy. Similarly, the other employee type is cashier. The cashier is also implementing the default behavior of employee, but it in this case this is leaf node. Why it's leaf node? Because it doesn't have any other hierarchy of employees inside it. The cashier may be working um, separately or singly, so it doesn't have any hierarchy of employees. Similarly, the other employee is accountant, and the accountant is also inheriting the default behavior of employee. But in this scenario, it is leaf, or it is single, or primitive. So we will implement this UML diagram into code in the next slide. The first class is the employee interface. This interface is the base class or the component interface, and it will contain the default behavior, default functionality, and the default properties of all kind of employee, such as ID, name, and the getter setter for all attributes, and the print method to display the all information of employee, and adding and removing, and the child management method, as well as the leaf classes and the child classes means the primitive object, and the composite object will implement this interface, the generic interface. The next class is the bank manager class, and it will be treated as composite object because it may contain other employees inside its hierarchy. So it will also implement the employee interface, the base interface for inheriting the default functionality and behavior of employee. And you can see inside the bank manager class the default functionality The setter getter, the constructor, the employee methods are implemented or the defined. And there is another extra information, which is that we are using the list data structure, because we know that the composite object will contain its own kind of object inside its hierarchy. So to store the employees inside the bank manager or the composite object, we have created a data structure which is list in this case of employee type, because we have defined the type of list as employee. So the bank manager, the object will contain different employees inside the list. And in the next, we will implement the child management methods for maintaining the list of employees inside this class. These are the child management methods for adding and removing the employees inside this composite employee. You can add the employee by calling the add method. Similarly, remove employee and get child method will return the current index employee, and the setter and getter for different properties such as ID and name. And the uniform operation, which is same for primitive and composite object, is print in this case. In this method, the all information and the properties of bank managers are being printed using SOP system.out.println. Similarly, it is also having the iterator to represent the children employee inside this manager class. So, using this iterator inside the loop, we will display the information of all sub employees inside this manager class, and the employee.print method will be called recursively. And why it's called recursively? Because it is uniform, it is same inside the composite as well as primitive employee objects. The cashier class will be treated as lead class because in the current requirement or the scenario, the cashier is not containing any other employee inside its hierarchy, but in future the requirements can grow and the cashier may have the junior cashier or any other employee. So the cashier can become the cashier class can become composite anytime from the for primitive, and you can add the child management method inside of it, as well as this data structure to store the hierarchy of other employees inside it. So, but in this case, it is treated as leaf and it will implement to the employee interface for inheriting the default behavior of employee. So, the same properties and the constructor, whereas you can see the add employee method is overridden because you have to compulsory override all methods from the abstract class, but you can keep it an empty. Why it's empty or no line is written? Because the this time at this time the employee is not functional for adding his children. It's primitive here, but in future when it will be composite, when the requirement will grow, you can implement or you can define for adding the employee functionality inside this. Similarly, the other get a setter for properties, and the uniform method, which is print in this case, is also defined here. In this, we are printing the properties, the default information of this employee. What do you think that why the iteration is not required at this print method? Because this is leaf node. Because the cashier doesn't have any other inside employee or don't have any child employee, so we don't need to use any iteration or recursion here for printing purpose. The accountant class is same as the cashier class. It is also treated as a leaf because at this level, the current information we are given, the accountant doesn't have any further employee or any hierarchy of employee. So, but you can make it also composite when the requirements will grow. So the inside functionality of this class is same as we have discussed in previous slide of cashier class. Similarly, the same uniform print method is also defined here by displaying the current information of accountant. And again, no need of any iterator because we don't have any hierarchy inside accountant class. The child management methods are empty because we don't have any functionality to define here, but when they become composite, you can define their behavior. This is our main demo class, which will contain the main method, and it will be treated as client class because it is using the employee interface for storing the information of employee in hierarchy or tree form. So inside the main method, you can see that employee 1, which is of type cashier, is created with following information. Similarly, the employee 2, which is again cashier, is created with the given information. The third employee is of type accountant with the given information. The fourth employee is manager with the information given. At this level, you have not created or defined any structure or hierarchy yet. But to create the hierarchy and the structure of employee and putting the employee in the composite employee, you have to connect these employees, or you have to design the tree. And using the composite design pattern, we can do it easily. The next statement are building the tree structure for displaying the representation of employees in a hierarchy. The first is the manager, which is composite. So manager 1 is adding the employee M1. Similarly, the manager 1 is adding the employee 2, which is cashier. And the third line, manager 1 is again adding the employee 3. And using the manager 1.print, we are not only printing the information of manager, the bank manager, but the recursive iteration inside the print method of manager will also display the child employees inside this hierarchy. So you can see the tree we have built using this composite design pattern. In this scenario, the root node is bank manager, and it has three children, three branches, three employees under his hierarchy, which are two cashier and one accountant. But to show you, we have taken very simple example. The information can grow, the requirement can grow. You can also add different employees, and you can connect them using this composite structure. And you can see that we are creating the uniform object, we are treating the composite object and the primitive object uniformly. Means the employees which doesn't have employees in their hierarchy, and the employee which are composite such as bank manager, we are treating them uniformly using the same operation, which is print in this case. So in the end, let's conclude what we have learned about the composite design pattern. Composite design pattern should be used when the clients ignore the difference between composition of objects and individual objects. You have learned easily that what is the difference between individual, primitive, and composite objects. So it is less complex in this situation to treat the primitive and composite objects in homogeneous way. Using the composite pattern, we are treating uniformly. We are treating them as a homogeneous objects, regardless they are primitive or composite. If programmers find that they are using multiple objects in the same way and often have nearly identical code to handle each of them, then composite is a good choice.